Hello, everyone, and welcome to the Grad Project Demo. My name is Curtis Evans, and I'm a Principal Academic Advocate here at AWS. Joining me today is Ben Lewis and Jesse Hahn from MIT. They're going to be sharing with us today some of the details of the criminal justice research that they're doing. Say hello, Jesse.
Hi everyone, I'm Jessie Xingyi Han. I'm a PhD student at MIT IDSS and also a research assistant at the policing lab at MIT. So my research interests are in fair causal inference for decision making in social science and life science.
Thank you for being here today, Jesse. And Ben?
Hi, everyone. My name is Ben Lewis. I am pursuing a Master of Science in Technology and Public Policy at MIT. I am also a researcher in the policing lab at MIT. My research interests primarily concern drug policy, as well as using AWS services to create a database for researchers to come to do their own criminal justice research. So before we get into this demo, I just want to explain why it's important for us to be doing this analysis. We're using New York City policing data to root out bias in the criminal justice system. As you know, wrong decisions in the criminal justice system can have very lasting impacts on individuals' lives. And what we're trying to do is use data to minimize those lasting impacts. So without further ado, I will pass it over to Jesse, who's going to start us off with how we read in the data. And yes, she'll start the demo for us.
So we're on Amazon SageMaker Studio Lab, and the first thing we want to make sure is that we are setting the kernel to default Python. And you can be doing this by clicking the top right corner and set the kernel to be this. And now we want to first install some libraries that we'll be using today. So the first is the geoplot, and the second thing is the OpenPyXL. Okay. And once we install the necessary libraries, we want to import all the Python packages. So there are some common ones that maybe some of you have seen in the past, like NumPy and Pandas. And there are some other things that probably some of you never heard of, like the GeoPandas, which will be a Python library that's specifically related to the geography. And also, like geoplot will be used to plot some like maps. Okay. So now we want to get into the details. So first, let's reading all the data sets. So we will be using the New York City data set, like policing stop data from 2003 till 2020. So we're just running this cell now. So some of the data files are in the CSV format, and some other files are in the Excel sheet formats. So this entire cell will probably take 2.5 minutes in total to run.
And just so our viewers are aware, the data sets that you're using is publicly available data, right? Just like we're using New York City, we could use practically any other city within the United States where data is available, correct?
Yeah. Yes, exactly.
So now, since we have already loaded all the data sets from all years, so we want to plot the number of stops between 2003 and 2020 to see if there's any trend of how the number of stops changes over the years. So now we're just onto this cell and do the plotting.
And this is a data plot in general. We're not filtering on any sorts of other characteristics. We're just looking at, from the date range, all of the police stops that have occurred within this time.
Yes, that's correct. Yeah. So we can definitely see that there are some changes over the years. Specifically, it seems like the number of stops reached like a peak around the year 2012 and started to kind of like decline drastically after that. So this change actually happens likely due to some policy reforms and administrative changes, and also the Floyd versus New York City court case happened in around like 2011 till 2014.
Wow, that was a great piece of analysis there, Jesse. It's very interesting to see that very steep decline in the total number of stops in New York City as a result of the decision that was rendered in the 2013 David Floyd versus New York City court case. Ben, care to talk about that case briefly?
Yeah, of course. So this case all started back in 2008 when David Floyd had alleged that the New York City Police Department had employed the stop and frisk policy on him without reasonable suspicion. And the reason why this is an issue, or why stop and frisk is an issue altogether, is that human beings are biased, and police officers are not left out of that category, right? And unfortunately, in this country, oftentimes people who are deemed to be suspicious oftentimes are minorities, African Americans, Hispanic Americans, and that can lead to some bias in policing. And so with this case, and with the decision in 2013, they decided to do away with stop and frisk because, we realized that it's unconstitutional.
And after 2013, and there are several policy reforms happening in New York City, and which might explain like the decline of the number of stops.
To me, I think it's great to see that an opportunity to be able to provide this kind of data may not even have to result in a court case in the future.
So for the first 14 years, we will be using the radio column for the information about whether the stops was initiated by 911 phone calls or by the police themselves. And for the later years, we'll be using another column called a stop was initiated. So we'll be running this cell and generate the specific variable called call initiate ratio. And we can plot this ratio to see how those stops were initiated. Just to add some more explanation, so the way we calculate the call initiate ratio is by first looking at how many it's by looking at if the specific column set to be yes or true. And we want to calculate the ratio of such cells and see how many of them or what is the proportion of the stops were initiated by the 911 phone calls.
So Jesse, basically what this graph is telling me is that since 2015, police in New York City are starting to rely more on 911 calls to initiate stops. Is that correct?
Yes, that's the way to interpret this result.
And I think that's a great thing, actually. So we see that police officers are using their time more wisely rather than just going up to individuals because they expect that the person potentially has drugs or weapons on them. Instead, they're relying on a dispatcher call that is showing that someone is in need of help or that there's an emergency, and they can use their time more wisely to respond to that rather than potentially, kind of looking for trouble. All right, great. So what we're going to do now is focus in on one specific year. So we're going to look at 2013. And as mentioned earlier, that court case that we were talking about, the New York City versus Floyd, that court case actually happened at the end of 2013. So we're going to zero in on 2013. And what I'm going to do is just walk us through some very simple reporting. We're going to look at tables. We're going to look at bar charts, and then we're going to look at grouped bar charts. So what we're going to first do is just read in specifically the 2013 data. Again, this is coming from a GitHub repository. We're going to pull that in using the read.csv function from pandas. And then this third line here is us just pulling in some specific columns that we want to look at because this NYC stop data has tons of columns, and honestly, we don't really need all of them. So that's what we'll go ahead and do here. Let me run this. Great. And now let's just take a really simple, look at the data at a glance. So we can use the .head function, and this will give us the first 5 rows of our data. So I'm just going to go ahead and run that.
And this function is helpful for any data set that anybody has read within a pandas data frame.
Exactly. Yeah. And it really just just gives you a good sense of one, what are the columns, and then maybe what are some of the different levels within the columns without having to look at the entire data set at once.
What if someone needed to read in more than just 5 rows of data?
That's a great question. So what you can go ahead and do here is just within these parentheses here, see if you wanted to look at the first 20 rows, you can just put 20 there. The default is 5, but you can change it to whatever. And then here you see it shows us the first 20 row. Well, it goes to 19, but that's because Python is 0 indexed. Yeah. Yeah, great question. So yeah, there's other things that we can do as well, right? So let's look at like how many rows we have in the data set. To do that, we'll just use the length function or len function and apply that to our NYC Stop 2013 data set. So here we will see that we have 191,851 rows. Similarly, we can just look at the columns in our data sets. So yeah, we'll look at the stop columns coming from the New York City stop data. And we'll use this dot columns function. And this will spit out the columns that we put in earlier. Yeah, I'll go ahead and like talk a little bit about some of these columns. So right here we have borough underscore masked. So we're looking at the 5 boroughs in New York City. And just to kind of like anonymize the data a little bit, we've masked them. So we're not saying like Manhattan, Queens, the Bronx. We've masked it so it's like A, B, C, D, or E. Here we have the race column, which is going to be something that we're zeroing in on. Again, we're part of the initiative on combating systemic racism. So race is a data point that we deal with a lot. So yeah, we have that in there. Again, I was saying also we have precinct, and then yeah, we'll have some others that we're going to change later and we'll talk through more later. So yeah, so like I just said, we're going to be cleaning the data. We're going to clean some of the columns. Yeah, and so that's what this chunk of code is doing. So I know maybe you can't see all of this on the screen. I'll like scroll back and forth so that you can see everything. Here we are renaming some of the columns. So like I said, race, we use that column a lot. We're going to change that to suspect race so that we know specifically we're not talking about the cop who was stopped. We're talking about the actual suspect. And then with this column, we're going to change that to suspected crime. Here, this RF underscore no L. This basically, yeah, we're changing this so that like it's more understandable for what, because no one really knows what that means. But yeah, this is us looking at the if the suspect had a prior aggressive crime on record at the time of their stop. And then a lot of these PF underscore whatever columns, these stand for police force stops. So we're going to change these to like stop force. So we change this one to stop force hands. Another stop force is like whether the person was put against a wall. Stop force on ground, whether the stop force included a weapon being drawn, a baton was used, pepper spray, and then we have stop force other.
I think this is a great feature for being able to explain police terminology a lot simpler to those who have, I would say, more of an interest within criminal justice data, but don't have a lot of experience with, some of the language of the criminal justice system.
Yeah, no, that's a really great point. Yeah, a lot of this we've had to like decode ourselves and look at some of the metadata that's coming from the New York City .gov website to kind of parse out what these mean. So yeah, that's a really good point. Yeah. And then, so more on some of the data cleaning. So for the suspect race, we're going to focus in on a few racial categories. They use letters to represent racial categories, but here we want to represent them as like the actual race, right? So some of these are pretty like straightforward, right? Like A for Asian, B for Black, but also, P also stands for Black, Q for Hispanic, and then W for white. So we just want to like make those very clear. And then at the end of this cell, or at the end of this like code chunk, we just want to print off the columns just to make sure that, they're doing exactly what we coded them to do. So I'll go ahead and run this. Great, and it looks like, this did exactly what we wanted.
So the output's now showing that for all of the instructions you passed for making changes to some of the column names, you now have those new values. So those new values represent.
Exactly, yeah. All of the columns that we changed now have the new names, and then all of the values that we changed, like within the race column, those are now changed as well, yeah. Okay, and then this next part, we'll just look at some missing values. It's always good to look at missing values in your data set just because if you have too many, sometimes, that data can be kind of like not really that helpful, right? So sometimes you might want to like filter out some of your NAs, or sometimes you may want to just like delete that column that has a lot of NAs just because it's not going to be useful. So let's go ahead and look at the NAs present in our data set, and it doesn't look like there's much. Most of our columns are full. Really the only one that has any NAs is this suspected crime column, and there's only 2. So not much to filter out there. I don't think we will filter out anything at all, actually. So now let's start looking at some of our like stop force values. And again, the reason why we want to look at this is because we want to make sure that like people are being treated fairly, right, when they're stopped by the police. We don't want certain people to have more aggressive stop forces than others based on, you know, the color of their skin or, you know, the language that they speak. We want to make sure that like there's parity among all people. So let's go ahead and look at these stop force values, and then we're going to see in our data how many times, like for instance, like there was a stop force that included hands or handcuffs or so on and so forth. So let's go ahead and run that. So this will output the number of times in our data set that particular stop force was used, and then the percentage of how often that particular stop force is used.
In other words, the higher percentages may oftentimes indicate that there may be a bigger problem that needs to be looked at or analyzed with regards to policing against a particular race or within a particular location.
Yeah, exactly. So here we're just looking at like, you know, in all the data sets among all different people, you know, how many times was stop force hands used or handcuffs? And we see that like hands is the number one stop force used, right? Ones that aren't used very often are baton, pepper spray. Those are used like in the teens. But it's usually like hands, handcuffs, you know, pushing someone up against the wall, things like that. Those are the most common.
Usually that means like hands and handcuffs are lower levels of force, and pepper spray and baton probably are higher levels of use of force. So police are using like hands and handcuffs more often than the other ones.
Yeah. Which is honestly a great thing because we don't want people to be having excess force used on them a lot of times,
Yes,
right? Like
exactly.
we want the least level of force to make sure that like people are being safe.
Yeah.
One would also hope that maybe through just better police tactics that the interactions with someone could result in something that's a little safer in terms of.
Yeah, exactly. So then let's look at some key categorical variables. And to do that, we're just going to use the value underscore counts function to see the amount of observations that we have for each of the categorical variables that we say are key to this data. And then from there, we will want to find some relationships between like race, location, police force. And so to do that, we'll just like count up the observations in each of these categorical variables. There's a list of the categorical variables that we'll be looking at here, and I'm just going to go ahead and run this. Again, this is just me like printing off, you know, race count and then looking at suspect race and then the value counts and doing that for these 5 key variables. Just going to go ahead and run that. I think. Yeah, I'll go ahead and run that. Okay. And so, yeah, there's some interesting things here. So we see that the racial demographic that's most represented in this data set is Black, followed by Hispanic, white, and then Asian, which seems to be heavily underrepresented. Again, these boroughs are masked, so you don't really know what each of these are, but I'll just go ahead and say that, yeah, like our most heavily represented borough is borough C, and then the least represented is borough E. All right, great. And then similarly, yeah, so we can look at some other categorical variables, like stop force handcuff and stop force firearm. And we'll see that, you know, about 9,500 people were stopped and were given handcuffs, and 639 cases, a firearm was used.
And just a quick reminder that these are basically statistics derived from New York City's specific stop call data from a given time range, correct? Or is this just for a single year?
Yes, this is 2013, and this is just police stops. So just the no call data, just police stops. And then they record data on the type of force that they use for each stop. All right, yeah. So then now we can look at some grouping. So say we want to see how many individuals of a specific race that's represented in a particular borough. So we can do that using this group by function. So we take the 2 variables of interest, suspect race and borough masked, and then we will group by suspect race to see this grouping. So let's go ahead and run that.
this starts to give us a little better insight into if whether or not a particular borough or precinct has some anomalies. Well, I'm not even sure if anomalies is the right term, but just some common statistics around certain data associated with race.
Yeah, exactly. We can yeah, kind of pinpoint in our certain precincts, sorry, our certain boroughs stopping people of certain races at a higher rate. That's kind of the reason why we're doing this grouping. Now we will look at we will group by races. Okay, yeah. So now we want to look at folks who are arrested and then group that by race. So we'll go ahead and run this. Okay, so again, what we're doing is we're looking at suspect race. We're seeing, based on race, were they arrested, yes or no, and then looking at count for that. Again, this is just like high level exploratory analysis, nothing too crazy, just to get a little bit of a sense of the data. We'll see that, again, most of the people who are being stopped, again, are Black, and then most of the people who are being arrested, again, are Black. And similarly, I guess the racial demographic that is, I guess, least likely to be stopped and least likely to be arrested is Asian. And then Hispanic and white are in the middle. And then if we want to get into more granular detail, we can do the exact same thing, produce the same chart, except instead of just looking at race and arrested flag, we can look at suspect race within a specific borough and then see the distribution of those who are arrested versus those who are just stopped and then released.
Okay, guys, so before we get into data visualization, I want to ask a few questions here. We've already talked about things like grouping. We've talked about things like categorical values. And this is all well done within the Python notebook. My question for you, though, is say I'm someone who's interested in criminal justice reform. Say I find this data out on a site somewhere and I want to be able to analyze it. Are you going to be able to provide me with some similar directions and instructions on how I can manipulate the data and use things like pandas and packages to be able to produce my own findings?
Yes, yeah, exactly. So no data is the same. Every city, every state has different ways of representing data, right? But you can use these exact same calls, and when we get to the data visualization piece, you can use the exact same visualization functions to visualize your data in whatever way you see fit.
Awesome.
All right, so now that we've done some, high level data exploration by just looking at tables, let's look at some data visualizations. Data visualizations are great because honestly, they're better to look at. Like just looking at tables of numbers, you can get a lot of information from it, but it's easier for the audience to read if you visualize it. So let's go ahead and do that. This was already read in earlier, but I'm just reading it again. We're importing matplotlib. This is a very popular library for data visualizations. Now let's see, so let's take a look at the number of people stopped in each borough by race. So to do that, we will make an object called borough by race that breaks down the number of people in each race for the 5 boroughs. And then we will use a for loop to loop through each borough so that we can look at the demographics for each borough in a bar chart. And so yeah, I just basically explained that. So what we're doing is we're making this borough by race, and then we're using this for loop to create our charts. This for loop does the loop for us. And then anytime you see this PLT dot whatever, these are us creating the bar plots.
They're basically methods within inside the library that you're using to create the visualizations.
Exactly. Yes. And so we can do different things like one, like plot that dot bar clearly makes the bar chart. If you want to, tool or mess around with the labels at all, we can do that for the X and Y. We can rotate things. So that means that like our ticks on our X axis, like say if we want to make those like 45 degrees, that's what we've done here. And then we can also add a title. We can show the plot and print some things.
So basically makes the results a lot more readable and easier to interpret.
Exactly. Yeah. And so here we have racial demographics for people stopped in borough A. Similarly, yeah, Black is the most represented, followed by Hispanic, White, then Asian. We can go through each borough and see very similar demographics. So yeah, so like I've said, we've looped through each of the boroughs and are looking at the racial demographics. So for the most part, we'll see that, as I've mentioned before, Black being the most highly represented, followed by Hispanic, White, and then Asian. For boroughs A through D, that's pretty much the same pattern. The only time we see something different is in borough E, where we see basically the representation for White and Hispanic has flipped. So it's Black, White, Hispanic, and then Asian. It's great to be able to do that and look at each of those boroughs separately, but and it's cool to like use a for loop. Those are always great, but we can also look at all this information all in one chart rather than looking at them through 5 different charts. So what we're going to do is use a grouped bar chart. So I'll go ahead and run that. Yeah, go ahead.
I was going to ask, so and where we're using borough in this case, which is represented in the data by a number of columns, this could easily be done for states, localities, and precincts that have counties or some other geographical representation of where they are. Boroughs in this case just happens to fit nicely within these data sets because there's 5 of them within New York City.
Yeah, and that helps, and that makes it easy, rather than having like hundreds of precincts and looping through all of those, or trying to make a chart that has like a grouped bar chart that has like 100 precincts. It's easier just to look at the boroughs. So yeah, that's a really great point. Yeah. So all of the data that we just looked at separately through those 5 different bar charts, let's just group them all in one bar chart. I'll go ahead and run this cell. And here we see similarly, so for each borough, A, B, C, D, and E, we have a count of how many people from each racial demographic are represented in that borough. Okay, and so now we can look at some other things. So let's look at this variable called suspect prior aggressive crime. So again, that represents whether or not the suspect is known to have a prior aggressive crime on their record at the time of their stop in this 2013 stop data. So we see that for the most part, people, across all racial categories, for the most part, do not have a prior of aggressive crimes. So yeah, most of the people that are being stopped are kind of like newly being stopped for something, that they do not have a past of. So now what we're going to do is look at the number of people by race in which a firearm was used in their stop interaction. Again, this is kind of a serious topic, but it's really important to make sure that certain racial groups aren't having, a more severe stop force, or aren't having to interact with the police officers where a more severe stop force is used. That's kind of the whole point of us doing this. So I'm going to go ahead and run this. This will spit out a plot that's by race, counting up the number of times a firearm was used in 2013 for a particular race. So in this chart, we're seeing that for the most part, the racial demographic that's most likely to have a firearm pulled on them is Black, followed by Hispanic, White, and Asian. Part of what's driving this is that most of the people that are being stopped in New York City in 2013 are Black. And so by, kind of like, so then the number of people who are having a firearm drawn against them are mostly going to be Black. Great, so now we're going to look at arrest rates, and specifically we're going to look at arrest rates for individuals who have a prior aggressive crime. So what we're going to do first is subset the data for, so we're going to use the suspect prior aggressive crime variable and just set that equal to Y, meaning yes. And then from there, we're going to look at the number of people. So yeah, we have to calculate the arrest rate. So first we're going to look at the number of people who are actually arrested in a particular race versus the total count of the number of people who are representative of that racial demographic in this subset of people who have prior aggressive crimes. Yes, so that is what all of this code is doing. I could walk through each of these lines, but basically just know that, again, we're subsetting for people who have an aggressive crime. We're counting up the people within that race category who were arrested, and then dividing that by the number of people who are in that race category.
So we're calculating, we're storing values, and we're making it ready for visualization in a few steps here.
Exactly, yes. So that's what we're doing here. And then kind of what we've been doing all along, we're going to do a bar plot or a bar chart just to visually represent that data. So I'll go ahead and run this. And I think this graph is pretty interesting, actually. As I mentioned earlier, the folks who are most heavily represented in this data are Black people or African Americans. People who are most likely to have a firearm used against them, again, are Black. But then here we see that the arrest rate is lowest among Black people in 2013 within this NYC Stop data. And I just find that pretty interesting. And it does kind of like highlight that there's a little bit of bias going on here, right? That people are being over-policed of a certain racial category. But at the end of the day, they're kind of like least likely to be arrested. So I just find that to be kind of interesting.
That is an interesting report.
We can also do a very similar thing by borough. The highest arrest rate by borough is in borough A, which you all don't know what that is, but that's in borough A, and it looks like borough C has the lowest arrest rate. So again, we're going to use a grouped bar chart to kind of look at what we just took a look at up here. These are arrest rates by race and by borough. But now we're going to look at arrest rates by race and by borough at the exact same time. Again, for people who have a prior aggressive crime. So I'm not going to go through each of these lines of code, but just know that we are calculating values. We're setting them equal to objects, and then we're going to use these objects later on in a bar plot that I'm going to go ahead and chart. So I've already run this. And here we get this beautiful, colorful chart where we see for each borough, what are the arrest rates by race, which are denoted in this legend here. That's all I have to show for you. Now I'm going to pass it over to Jessie, who's going to walk through this thing called principal components analysis, which she can explain more later. But basically, I'm going to go ahead and pass it over to you.
So now let's explain what PCA actually means. So principal component analysis is a way to reduce dimensionality of the data. So if you have a very high dimensional data, similar to our case here, like the forces stacked, which has like 77 times 208 dimensionalities, then you probably want to use a way to like a method to reduce your dimensionality so that you can better visualize your data and understand what is the information out there. And also you can use PCA to extract the most significant signals in your data so that you can remove the noises and only retain the most information in your hand.
Yeah, so let's like maybe give an example of that using maybe a streaming service example. So when you log into a streaming service, you give that streaming service tons of information, right? Like, your age, where you're logging in from, how many times you're watching a show, what types of shows you're watching, just tons and tons and tons of information. Well, for that streaming service to recommend shows for you or movies or whatever, it wants to zero in on like what's the most important information. That's what principal component analysis is doing. It's taking all of that data that you're giving, say, for instance, a streaming service, or in this case, police data, and it's just zeroing in on the pieces of information that differentiate the data points the best.
So now we want to take a closer look at the use of force part of this data. So specifically, we want to understand how the police actually use force against the civilians. So so first we want to encode a new column called force 2, which will be telling us whether there is any level of force being used in a specific stop. So specifically, we just look at all the different forces Ben just showed, like different, like some force level can be hands, handcuffs, against the wall, and there can be higher levels of forces like pepper spray and others. So if any of them was used during a stop, the force 2 will be set to be true. yeah, and so now I'm just running this cell, and it tells us that among all the stops, there are 18.24% of the stops where any level of force was used. So now we want to use a default function in data frame to convert the date of the stop from text to datetime objects for easier processing of the data. So yeah, this will take a few seconds. So specifically, we want to enter like the specific format of the text of the datetime, so that the method knows like how to actually encode and decode the datetime. Yeah, and once we have the datetime processed, we can now transform the use of force data of each race into weekly results, so that we have like a more structured way of looking at the data. And this function does that exactly. So first we want to have the dates of each week, and then we want to do the processing for each race. So we have Black, White, Hispanic, and Asian. And then for each, we will group the data sets into results of each precinct. So we have actually around 77 precincts in New York City. So we want to do that for each precinct and calculate the number of stops happen in that precinct and also in that specific week, so that we have like a very structured format of the data. So the results will be stored in this variable called forces stacked. So now we have all the data in forces stacked. It's the shape of this variable, this NumPy array, is 77 times 208. So basically, this means that there are 77 precincts, and there are 52 weeks times 4 different races. So that's going to be 208 in total. Yeah. So this is a very high dimensional data. So we want to, it's very hard for us to actually read it or interpret it because it's so high dimensional. So we also print out the explained variation per principal component here. So this is an array, and we start with the 0.5788, which means that the first principal component explains 0.5788 of the variation in the data. And the second explains 0.0978 of the variation, and the third explains 0.04-ish, and the fourth explains 0.037-ish of the variation. So the higher the number is, which shows that the more important this principal component is. So now we're down to the 8 principal components. But we still want to understand if there is any pattern within the 8 principal components. So we now using unsupervised machine learning technique called k-means to cluster the 8 principal components. And specifically, we want to try if we iterate over a bunch of parameters, like which are the different numbers of clusters we want to try out, and see if some number of clusters work better than the others. So specifically, we start with 3 clusters to 4 clusters to like 10 different clusters, and we hope to see if the lower dimension data can be grouped into a certain number of clusters. So now we're just calling k-means here and iterate over different number of clusters from 3 to 10. And this specific score here tells us like how good this clustering is. And the higher number means like the better clustering. So we can see that here, if we set the number of clusters to be 4, the score is the highest, which is 0.30. And so now we just set, we're determined to continue with 4 clusters, and we assign 4 colors here for visualization. And basically, we just rerun the k-means again and extract the labels, like basically tells us like which cluster this specific data point belongs to. so that we have, yeah. And then we want to plot the results in a 2D plots where we have one dot for each precinct, and we have 4 different clusters. So the color denotes which cluster this precinct belongs to. So the red is cluster 1, and the greenish color represents this is cluster 3, and the yellowish means this belongs to cluster 2, and the bluish color means that those precincts belong to cluster 0. Yeah. So yeah, so this is like a 2D plot. Still, like it probably does not give us much intuition on how this actually looks like in New York City. So now we want to plot the geographic information of New York City and color code each precinct based on the cluster this precinct belongs to. So first, we just want to reading a bunch of information, like geographic information about New York City. And then we can add the labels from the k-means clustering for each precinct. And then we can do the plots. So this is the result. So we can see that like different precincts are now color coded based on different clusters they belong to. So we have a bunch of red colors here and also blue, yellow, and greenish. And so this actually we if we take a look at the the race and ethnicity distribution in real world, which is shown here. I guess I need to zoom in a little bit. Yeah. Which is this is ground truth. This is what exactly it is like in real world. I think and we can see that these 2 plots actually coincide with each other to a very high extent. So we can see that like this red parts fit exactly with like the real world data here, like the red part here. So the red actually means those precincts are white dominated, like the white is the majority in that precinct. And the yellow means that these precincts, the Hispanic is the majority. And then the bluish means that African American are the majorities in these precincts, and the greenish color represent those precincts which are Asian being the majority. So we can see that the PCA and k-means actually capture those information in the New York stop and frisk data sets.
Wow, this is really amazing work, you guys. Really dive into a very important topic here. When your final data set is ready to be made available to the public, who do you foresee being able to use this data and in what ways?
Yeah, we hope everyone will be able to access this data set, but we especially hope that the policymakers can take a closer look at the data sets and get insights from it, and so that they can understand how their policies are affecting the general public, so that we can working towards a more just and equitable society.
Okay, that wraps up our demonstration. I want to thank Jesse and Ben for joining us today, and I would like to invite everyone to go to the Grad Project GitHub repo so that they can download all of the assets and run within Amazon SageMaker Studio Labs for themselves. Have a great day and build on.